All right, today's lesson is on volume. What's our objective? Get ready?
Volume.
Volume is so pertinent to our world. So, for example, what is the volume of water that we need to fill into a swimming pool? How much sand would fill a sand volleyball court? Or how much air needs to fill a room so that we can calculate what kind of furnace needs to heat and cool an entire building? So Mr. Van Tassel probably had to help be involved with the furnace to make sure we could cool and heat our school, but how strong of a furnace was needed for our entire school? They had to know how much airspace are we heating and cooling, right? Well, the airspace is volume. How much volume does our school take up? So we're going to talk about how to calculate volume. It is the total amount of space occupied or enclosed by a solid, and we measure it in cubic units. So let's see what we mean. So look at this cube. It's in 3 dimensions. It has a length, it has a width, and it has a height. And it has all these cubes broken up. We're going to count how many cubic units are in here just by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this front layer has 20 cubic units. We're in inches actually, but I'm going to say cubes. The second layer would have another 20, and the third layer would have another 20. So couldn't I take the front face, since I know the area of this front face, and multiply by the depth of it? Multiply by, so 20 times 3, and that would give me the whole volume of everything. So that's 60 total cubes. Well, the shortcut way to do it, we're going to talk about, is the volume is the length times width times height, or really the area of the base times the height. So the length is 5, width is 3, height is 4. If I turned it on its side, does length, width, and height have a different meaning? If I turned it again, length, width, and height, can I really interchange them a little bit? Length, width, and height. Okay? So 5 times 3 would be 15, times 4 is, there's our 60. And we've got inches times inches times inches. Inch times inch times inch. Well, mathematicians don't want to write inches 3 times. So instead we write inches cubed. So our units are cubed in volume. What are our units in volume? Get ready?
Cubed.
Cubed. Very good. So that leads us to the general formula for volume of a prism. It is the volume equals area of the base times height. What's the volume equal to for a prism? Get ready?
Area of the base times height.
Good. Area of the base times the height. How is that applicable and how does that help us? Because if you have a prism that's got a weird base, for example, maybe your base is like this, and your building is like this, right? Okay? So it wouldn't matter how tall the building is, as long as I could find the area of that base, and I could multiply it by how tall it is, I could find out the volume, even with these weird shapes and cutouts. But let's start simple, and let's talk about the volume of a rectangular prism. Volume of a rectangular prism is, actually we brought it up already, length times width times height. What's the volume of a rectangular prism? Get ready?
Length times width times height.
Length times width times height, because a rectangular prism, we're talking about just very simple, we drew the other day. Okay, we've got a base and we have a height. So as long as we can find the area of that base, oh sorry, length times width times height. Length, width, and height. We're going to multiply all 3 together. So let's try this one. We've got a building, it's 30 by 30 by 10. And we need to heat and cool. So we need to figure out its volume. Since it's a rectangular prism, we can use the easy formula. Length times width times height. What's the formula for volume? Get ready?
Length times width times height.
Good. Length times width times height. So 30 times 10, they're all feet. I'm going to put the units on at the end. So 3 times 3 is 9 with 2 zeros times another 10. That gives me 900 with an extra 0. Throw our units on feet, 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 right? Feet, feet, feet. There's 3 of them. I don't want to write them 3 times, so I'm going to use cubed. 9,000 feet cubed. Any questions? Preston? They are. If you see the formula on my poster, I'll point to it. If you think it's on the bottom right, there it is, okay? So here's your volume of a right prism. Here's your volume of a rectangular prism. So if you forget, there they are. Okay, got a couple more. How about this cube? Now a cube, oops, we lost some bad ink. So the cube's got the same measurements all around. That's the definition of a cube, right? All sides are equal. 2 by 2 by 2. So let's find the volume quickly. Length times width times height. 2 times 2 times 2, which is 8 feet cubed. But I'm not done. I got to read the rest of the question. It says at 57 pounds per cubic foot, what did the 2-foot cube weigh? Well, if I broke it down and kind of visualized, what are we talking about here? If I broke it down into, here's a cubic foot, and that's a cubic foot, right? If this is 2 across, there's 1 foot, 1 foot. So each one of these little cubes in here weighs 57 pounds, right? 57 pounds, 57, 57. And how about the back layer? Wouldn't the back layer also have 4 of those cubes? I have a total of 8 cubes, right? Each cube weighs 57 pounds. Let's multiply that. 8 times 7, 56. 8 times 5 is 40, plus the 5 is 45. 456 pounds in that whole cube. So you see how this is really relevant applications there. What if we have the odd-shaped building where we can find the area of that odd-shaped base and multiply it by the height to find our volume? So, let's see if I got a better marker. First of all, volume of any prism, area of the base times height. What is the volume equal to? Get ready?
Area of the base times height.
Well, let's just call this L shape my base. I'm going to redraw it as an L, and I'm going to label it up. This side's 12, this side's 12, this side's, remember yesterday we talked about that top view? This side's 20. See how I've just taken it and I'm looking straight down on it now? Can I find the area of this L shape? This piece right here? So let's do that. Let's break it into 2 rectangles. I got a 12 by 12. 12 times 12, think. Okay, ready?
144.
Good. 144. We're going to be square feet still. How about this one? I've got a length or a width here, but I need this distance. Help me find this distance. How did I get that? Okay, Liesl?
You would add 12 plus 15 because they are the 2 sections. They're like that width.
Okay, this 12 is this distance here. This 15 is this one. So this is 12 plus 15. That gives me 27. So I'm going to go 27 times 20. So I'm going to take that 2, double my 27. That's 54. Throw in my 0. There's 54. 540. This area plus this area is my combined area of my L shape. 4, 8, and 6. Now that's, let's see, 684 square feet. That's just the base. Or top, it's the same, right? But I need volume, so now I'm going to multiply by the height, which is 10. So my overall volume is 684 feet squared times 10. Throw on that extra 0, 6840 feet cubed. Because this one had an extra feet unit. Give me the feet cubed. Give me a thumbs up if it made sense. Okay? Put your hands up if you knew this from last year and you remembered it from last year. Okay, a lot of you, okay? So some of you is probably a little bit newer, just a good kind of reminder. Okay, it's your turn. Find me the volume of this cube, and all you know about it is one side is 10 centimeters, but you do know it's a cube. As soon as you've got the volume, put your pencil up. Good. 1, 2, 3, 4, 5, 6. Remember your units. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Let's do this as a class. What is the answer? Get ready?
1,000 centimeters cubed.
You guys are awesome. 10 by 10 by 10. 10 times 10 times 10 is 1,000 centimeters, 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 centimeters cubed. Perfect. And we are on the practice set. Problems are A and E.